Okay, let's talk about a little bit about chemistry and introduction to chemistry. What is chemistry? It is the science of matter, and matter is anything that has mass and takes up space. And in this class, we probably will go over an overview of composition of matter, structure of these matters, properties, reactions, and also energetics of matter. And then we do experiments, interpret these data, and obviously research labs, the research chemists, they work on synthesizing new substances. All right, so let's take a look at water. If we want to take a look at microscopic view of water, it's actually H2O. We know we hear H2O all the time. So this is how it's bonded. The H is bonded to an O and then to an H right here. And it's sort of like, I guess it looks like a little teddy bear right now, but that's how it's going to be shaped. So H down to O, O up to H, like that. And this is water. If you had anything that's a little different, say like an extra O, so instead of H2O, we have H2O2. That actually makes it something completely different. Looks pretty similar, but it isn't. H2O2 is actually hydrogen peroxide, and we probably should not be drinking that, but we can clearly drink water. So one atom off, but completely different properties. All right, so the scientific method in chemistry here, what we want to do is we want to first look at any data that we already know of, or maybe do a preliminary experiment and then take a look at the data. So what are your current observations? Based on your observations there, you can formulate a hypothesis, which is a tentative explanation. So you're tentatively trying to explain what you've been seeing, okay? But then you just say, I think this is why, but let's prove it using an experiment. So then we do more experiment to test the hypothesis. If the hypothesis is good, we keep it. If not, we modify it and we keep testing it. A useful hypothesis should explain all the observation or data that we see. Hypothesis is tested over and over and over, and it's reported supported by repeated experimentation. We call it a theory. So theories are basically well-established hypotheses, like it's been proven. Okay, and theory is only true as long as there's no evidence to disprove it. So it's only valid as long as there's no evidence to disprove it. So if you came up with a theory and I found an evidence that could disprove it, then the theory is no longer a theory. Okay, so on the other hand, scientific law is basically a summary or statement of all our natural observations that we've been seeing. So let's take a look. If you have observations here, from the observations, you can have a set of laws saying like, I always see this happen. For example, if I observe water being heated, eventually it turned to water vapor. Okay, so that's just something like, oh, that's always true. And then we have observations, and then we come up with hypothesis. We do more experiment, we can modify hypothesis, or we can prove it to a theory. All right, so let's take a look at matter. Okay, so matter obviously deal with on a microscopic level. We're all going to be looking at atoms. All matter is composed of atoms. And we have three states that we want to talk about: solid, liquid, and gas. Solid, we all know what it is. It has definite shape and volume and doesn't really need a container, it can stand on its own. So the most important thing about solids is we have two types that we're going to learn about. We have crystalline solids. They're called crystalline because the atoms in there have regular and repeating 3D patterns. Okay, so like it just repeats itself over and over like a predicted spot. Like if it's one in the middle and then three on the side, it's always going to be one in the middle, three on the side, all over in 3D dimension. Okay, so that's crystalline solids right there. So if we take a look, water molecules are going to be held together in a certain pattern, and it creates ice if it's held to a certain distance that creates ice. Okay, so ice in this case would be crystalline. What else can be crystalline? Well, we can talk like diamonds. It's always certain arrangement. Diamonds are made out of carbon, and if the carbon is arranged in a certain way in a pattern, it becomes diamond. Okay. The opposite of crystalline solid is amorphous solid. So let's take a look at that. Amorphous solids have no patterns. There's no regular patterns, nothing is just blob. All the pieces of atoms are stuck together. So examples are plastics, glass, and gels. No shape or form. It's just pieces of atoms close together. So liquid is a little looser than solid if you look at it in a microscopic view. Solids are held close together. Liquid is held still close together, but a little bit further apart so they can move freely. And that's why you can pour liquid. And you can, pour them from one container to another container. Now, right here it says, see, it's close together, but still free to move around and slide over each other. So on the other hand, gas, they're super, super, super far apart from each other, okay, compared to solid and liquid. And the distance between them is really, really far, so you can easily compress them or actually expand them. So it moves really, the molecules are far apart and they move freely. So example would be water that turns to gas form into steam. So what's the difference between, say, ice, liquid water, and steam? They're all H2O in this case, right? But they all are held at different amounts of, I guess, attractive forces holding them together. Solids are close together, so they're rigid. A little bit weaker in liquids, so they can still move around, slide around, can be poured from one container to another container. And gases are completely so far apart. The attractive force holding them together is really weak. All right, so here are some examples of solids, liquid, and gases. We all have heard of aluminum solid. We have copper solid, gold solid, all kinds of solids here. But we don't have to memorize these. It's just kind of fun to take a look at them. Liquid alcohols, we know about alcohol, blood, gasoline, honey, mercury. Gases, obviously we breathe in air, so that's important for us to know. Butane is used as a fuel. Carbon dioxide, we know that too. When we breathe out carbon dioxide. And we also have chlorine gas, helium gas, we probably have used in helium balloons, methane, and nitrogen. So let's keep going. All right, so when we talk about matter, the first thing is we are going to split into categories. The first thing we want to talk about is pure substance. So anything that's pure, basically it's not mixed with anything else. It's just that thing by itself, okay? So if it's just sugar over here, that sugar is pure. If it's just water here, that water is pure. These two are called compounds. So why are they compounds? Compounds are basically, when you break it down, it's like not just one atom, it's going to be multiple atoms in there. Okay, it's like sugar is actually a bunch of carbons, hydrogens, and oxygens bonded together. And water, obviously, we know it was H2O. And H2O is a compound. So when we talk about matter, we also want to talk about homogeneous matter. That means it's even throughout the whole thing, evenly distributed. Okay, heterogeneous matter, it's not evenly distributed. So one side can be different from the other side. A phase is a homogeneous part of a system separate by other parts with a physical boundary. So like saying, we can have oil and water. That's two phases, right? A phase of water, which is homogeneous, or a phase of oil, which is homogeneous. Another example is ice floating in water. So if you have ice and water, obviously these both are H2O. It's two-phase system. Each phase is homogeneous because one side is ice. Each phase, the ice is ice. It's evenly throughout. Water is water evenly throughout. But overall, the system is heterogeneous because it's not evenly distributed because ice always floats to the top. So on the top, you get more ice. On the bottom, there's going to not be any ice. All right, when we talk about mixture, we mix two or more things together. And homogeneous mixture is where everything is evenly mixed. Heterogeneous mixture is going to be not evenly mixed. So example in this case of homogeneous mixture that they gave us is like I guess syrup. This is sugar syrup. And the whole way through it's going to be evenly mixed at every point on the top or on the bottom. You will have the same amount of sugar and water mixed together. Heterogeneous is the opposite. It's going to be different. Oil and water, heterogeneous. So like salad dressings, like Italian dressing where you have oil and vinegar or anything like that, then it's never going to be homogeneous because they try to separate, and usually the thing that's a lighter density will float to the top, right? So the oil is always going to be on the top and the rest of the dressing is on the bottom. So that's heterogeneous mixture. Another example of heterogeneous mixture is when, say, if you wanted like sweet tea, but they didn't have sweet tea, so they gave you tea, but it's cold, and you put some sugar in it, you try to dissolve it, but it's not really going to dissolve it homogeneously because you kind of need to, sugar dissolves a lot easier when it's warm. So that cup of tea with sugar on the bottom and not sweet on the top, that's going to be a heterogeneous mixture. Now, if it was a sweet tea made in a restaurant, pre-made sweet tea, then that would be homogeneous mixture because you expect it all to be sweet throughout the entire glass of sweet tea. So over here, next thing is we want to talk about separation of these mixtures. You can separate them using a lot of different ways, but one cool thing is, you see here, we have sulfur and we have iron. Obviously, iron is magnetic, but if you pour them together, like you mix them up, you can actually pull the iron up using a magnet. So that's pretty cool. That's magnetism to separate them. Mixtures can be separated by physical means, and they don't lose their identity. So you just kind of like plop them together, basically. Flotation, anything that's lighter and a smaller density will float up, and you can maybe like pick up stuff that will float, and the heavier the stuff that's higher density will sink down. So you can separate them that way. Filtration, say if you want to filter solid and liquid, like say if you boil some pasta in water and you want to separate the solid pasta from the water, you just use a filter, a funnel, right? In our case, in the kitchen, we use a colander. So that's filtration. You can also boil stuff like saying different liquids will have different boiling points, so you can boil them and say alcohol will boil before water, and you could separate alcohol from water that way. So let's go over a few questions here. What is the chemistry of science? So it says the science of chemistry may involve A, observation, B, hypothesis development, C, experimentation, D, all of these choices. So I would go with D, all of these choices, because these are all in the scientific method that we talked about. So out of these four choices here, which one is an observation? Atoms consist of protons, neutrons, and electrons. All matter is composed of atoms. Water is colorless. Atoms can form chemical bonds by sharing electrons. So out of these four, I believe C is an observation right there. All right, let's go on. The next question, they talk about which one of the following is a homogeneous mixture. So homogeneous mixture is something that's completely mixed overall, like our sweet tea, right? And it's mixed evenly throughout the whole thing. So carbon dioxide is not even a mixture. Carbon dioxide is CO2. It is a compound, but it's pure by itself. Mercury is just mercury by itself, and it's going to be an element because mercury is just one element. Carbon dioxide is a compound because it has carbon and oxygen, because we know it's CO2, right? It's one C, two O's. So let's write it down. This guy is CO2, and this guy is mercury is just Hg. So that's one thing by itself from the periodic table. I'll show you guys that. But that's how we know that. Okay, so these two A and B are pure. Okay, maple syrup. Maple syrup is, it's got a lot of stuff in it. Like, I mean, obviously it's a liquid, but it's got a bunch of sugars. But it's always evenly mixed, right? So I would say C is our answer right here. But let's take a look at all the other options that we have first. Concrete. What is concrete? Concrete is actually a mixture of different stuff. It's water, cement, sand, rocks, and stone, and it's not evenly distributed. So concrete would actually be an example of heterogeneous mixture. Okay, so maple syrup is homogeneous mixture. Concrete is going to be heterogeneous mixture. The Italian salad dressing we talked about, that's also heterogeneous. All right, so let's take a look at the next question. A tentative explanation for certain facts that provide the basis for further experimentation. So further experimentation and tentative experiment explanation. What is the answer? A, observation, B, hypothesis, C, theory, and D, law. I would say this is a hypothesis. All right, so which of the following is a heterogeneous mixture? Heterogeneous mixture, remember, is not evenly mixed, okay? So baking soda is baking. So obviously you don't know this right now, but let me. Baking soda is actually sodium bicarbonate, which you will learn. So it's a compound. This is the formula: NaHCO3. But there's nothing else mixed with it. It's just baking soda. So it's not even a mixture. It's a pure compound because it got more than one type of element in it. It has 1, 2, 3, 4 types of elements in it. Okay, so gasoline. Gasoline better not be a heterogeneous mixture, because if you pump gas in your car and it's not even, how is your engine going to work, right? So gasoline is actually a homogeneous mixture right there. Okay, grape juice. Grape juice should be homogeneous too, because it's gonna be like overall juicy. Like, it's not gonna be one side sweet and one side not sweet, or one side purple and one side not purple, depending on what color the juice is. Copper metal is pure because it's just pure copper. It's actually a pure element right here. Okay, so soil should be our answer here, because soil has different things in it and it's not always evenly mixed. So soil should be our answer right there for heterogeneous mixture. All right, so let's take a look. The next question says, which of the following is a pure substance? Tap water. Tap water is actually mixed with a bunch of different stuff in it. That's why we gotta purify it, right? It has different ions in it, plus water. So a trail mix is definitely a mix of different things, so it's not pure. We are looking for pure substance. Seawater is also a mixture of water, salts, and a bunch of other stuff. So A, B, C are mixtures. Deionized water means it's just water with no ions in it, so definitely just pure water. So our answer here should be D. Which matter contains the greatest force of attraction between particles? Now remember, the greatest force of attraction is between solids. Next the next in line would be liquid, and then the weakest one will be gas, right? So we are looking for something that's a solid here. So oxygen gas is going to be the weakest. Mercury exists as a liquid. You see like mercury in your thermometer, it's a liquid, right? Okay, sodium metal, that's a metal. Sodium metal, metal is solid, right? So our answer should be sodium metal because the next option is liquid, bromine. So liquid is less, and then gas is even smaller. So sodium metal should be our answer right here. All right, next question. In which of the following classifications would a solution be placed? Solution, remember, all solution is something that's at least two things mixed together, and they have to be evenly mixed. Okay, so solution is going to be a homogeneous mixture. That's a definition, actually. So all solutions are homogeneous mixtures. Now, which of the following is classified as a solution? Air, liquid water, solid iron, soil. So we know soil is not a solution because we just said soil was heterogeneous, right? We need something that's homogeneous. Iron is not a mixture. Water is not a mixture. Air is a mixture, correct? Because we know air has different gases in it. And we would be in trouble if one side of the room had different air than the other side, correct? So air is a homogeneous mixture, and it would be called a solution. The answer here is A. All right, let's go to the last question. Which of the following is not an element? Element means one thing by itself, okay? Copper wire is an element. Oxygen gas, just oxygen gas, that's an element. Mercury is also just by itself, that's an element. Dry ice, do you guys know what dry ice is? Dry ice is actually CO2 in solid form. So we know CO2 gas is what we breathe out, and the plants need CO2 gas, right? But dry ice is CO2 solid. So that's not an element because it's a compound. It's carbon dioxide. And that's it for chapter 1.